Okay, here we are talking about normal distribution again. Just let's take a look at the curve now and see what happens with that curve. So anything that occurs in nature, normally distributed usually. And the way this normal distribution works again is the measurements would be along the x-axis, frequencies would be on the y-axis. It just so happens that normal distribution is symmetrical about the mean. Okay, and we already talked about in the last video, the first standard deviation occurs at the inflection point of that curve, which means that this value here on our x-axis would be the mean plus 1 standard deviation, because this is a standard deviation away from the mean. Okay, we could therefore go back in the other direction as well. Inflection point, 1 standard deviation away, same distance as this, and we have the mean subtract that standard deviation is what that x value on our x-axis would be. We can go another standard deviation distance away, and this value then would be the mean plus 2 standard deviations, and so on. Another distance away of the standard deviation, the mean plus 3 standard deviations, and so on. Let's go back in this direction. Mean minus 2 standard deviations, mean minus 3 standard deviations. Okay, all of these distances, these intervals in between, are equal, and they are equal on the x-axis measurement to the standard deviation. Now, the interesting thing about the normal distribution is that within each of these areas on our curve, a certain percentage of the data exists. So in here, we have actually 34.13% of the data lies within 1 standard deviation below the mean and the mean. Since normal distribution is symmetrical, that also means that 34.13% of the data is here. That also means that if we look at this entire space, this entire area under the curve, we would add those two together to get 68% of the data is within 1 standard deviation of the mean. 1 standard deviation below the mean and 1 standard deviation above the mean. So 68 in IB math, we'd say 68.3% if we were rounding it, because 3 significant digits unless told otherwise. All right, the next section out underneath of our curve has 13.59% of the data. And so similarly over here, 13.59% of the data. The next section out has 2.15% of the data. 2.15% of the data also out here. And the last one, 0.13% of the data is beyond that 3 standard deviations to the right, and 0.13% of the data is beyond 3 standard deviations to the left. All right, all of these percentages together should add up to 100%, just like a normal probability distribution. Or if we're dealing in decimals, that would add up to 1. All right, let's look at an example. Example 1 from your textbook, page 634. We're looking at chest measurements of 18-year-old footballers. Okay, so 18-year-old footballers is normally distributed. As soon as you see that phrase, is normally distributed, you can write down that notation. We're dealing with x is distributed normally. We now know we're going to be dealing with a normal distribution curve, so just draw that as well. We'll be able to put our information on it. With a mean of 95, okay, so the mean goes here, and a standard deviation of 8. Okay, variance goes in here, so we can just say 8 squared, so we know the standard deviation is 8. All right, let's draw this on our diagram. We know the mean is here, and the mean is 95, so this will be 95 centimeter measurement. Standard deviation is 8, so if we add 8 to 95, and come over 1 standard deviation away, then this value will be 103. Move another standard deviation, 111. Another one, keep on adding 8 because 8 is the standard deviation, 119. All right, back the other way. Subtract 8 and we get what? 87. Another standard deviation, subtract it, and we get 79. And another one, we get 71. Okay. Now we know the percentages within here. We just talked about those percentages. So we know, rummaging through here for my colors, we know that here is 34.13% of the data. Here also 34.13%. Here 13.59%. Same with here. Here 2.15. And out here 0.13%. All right, now let's get ready to answer our questions. We've got all of our preliminary work done. First question. Use blue. Find the percentage of footballers with chest measurements between 87 and 103. Okay, well here's 87, here's 103. 87 and 103. So that's these two areas, 34.13 plus 34.13. Add that together, that's going to give us the 68.3% rounded to 3 significant digits. Okay, we just added it back in the other place. All right, next part. Find the percentage of footballers with chest measurements between 103 and 111. Okay, so look between 103 and 111. What percentage is supposed to be there? 13.59%. So that answer, 13.6%. Okay. Part B, find the probability that a randomly selected footballer, okay, so again, that's important. We're dealing with random variables. Randomly selected footballer is between 87 and 111 centimeters. There's 87, there's 111. What do those probabilities all add up to be? So 34.13, 34.13, and 13.59. 11, 8. So 81.9% rounded to 3. 81.9%. And the question was asking, find the probability that a randomly selected footballer is between 87 and 111. So 81.9% of footballers, based on this sample, will give us that. Okay, C, find the value of K such that approximately 16% of chest measurements are below K. All right, so here we're looking for below K. We're looking for below, so 16%. So starting on this side, how many of these add up to give us 16%? Well, there's 0.13, 2.15, 13.59. I'm guessing that might be close to our answer. Let's add them up. 17, 6, 7, 8. 15.87, which is pretty close to 16%. If we go any higher, we're getting into some bigger numbers already. So this would be, did I add up correctly? 14, 17, 6, 7, 8. Yep. Okay, good. Yep. So therefore, what value will K be to have those 8, to have that 16% smaller than K? Well then, K actually equals 87 in that case. There we have it, your first example for what we can do with a normal distribution curve.